Good day to you all. Evan Snellman here for Umahluko, Making a Difference. So today we're going to look at the method to find the equation of a circle in a analytical context. As always, you need to know three skills, and effectively the three skills are to get from an equation to the graph, to get from the graph back to the equation, and then if they gave you both the graph and the equation, your ability to know and interpret its features. And so today what we're looking at is we're looking at the second of these, how to get from the graph back to the equation. Firstly, remember that the equation for a circle is x minus a squared plus y minus b squared equals r squared, where the two key concepts are that the circle center will be a and b, and that the radius will be that. So we know that the circle center will be a semicolon b, and we know that the radius of the circle will be r. So again, please take note. These are two goals: is to find the circle center and what effectively will be the radius of the circle. So we're going to now proceed to look at some examples. Again, keep in mind that these are two goals to determine the circle center. That will probably come from either the diagram or from other information. And to determine the radius of the circle, again, either clear from the diagram or from the equation of the circle. Okay, so here we've got two pictures. Again, we are assuming that each grid in this picture is unit 1. So all we need to do here in this particular case is do some counting. Okay, so we can see that this is 1, 2, 3, 4, 5 to the left. So it's got a center at -5. And if we count it up, it's got 1, 2, 3, 4 up. So it is centered at the point -5, 4. And then again, because of its shape, we can see that the radius is clearly 5. So as a result, we can go to our formula. Again, x minus a squared plus y minus b squared equals r squared. And as a result, simply plug those values in. We're going to have x plus 5 squared plus y minus 4 squared equals, in this case, I'm going to change this to blue, 25. And again, the real question which you need to ask yourself is, why is it 5? And the reason it is 5 is 25 is because 25 is 5 squared. So there we have our first equation. We are done. It's not too complicated, and as a result, we can speed through the second one and go a little bit faster. We can see that thing's center is at 1 and -3. We can see from here going across that the radius is 4. So we've got x minus 1 squared plus y plus 3 squared equals 16. And again, I would really encourage you to try and do this thing by inspection rather than doing a whole bunch of substitution and getting minus signs, making silly minus sign errors. Okay, so again, these are definitely considered to be straightforward marks, and would encourage you to be quite hard on yourself if you aren't getting these marks easily. Okay, now again, they don't always give you the diagram. Here is an example where they don't give you the diagram. Give the equation of a circle that is tangent to the x-axis. Okay, so again, let's see if we can make sense of it. we've got the, okay, it is tangent to the x-axis and sorry, excuse me, and has a center of 5 minus 7. So let's have a look at that. Okay, so it's going to have a center at 5 across and 7 down. So there's its center. And this graph, this picture, is tangent to the x-axis. So in other words, it is just touching the x-axis. And so we are going to have a picture graph that does, sorry, it's not my best circle, but a graph that does something along that line. And we know that the center is at 5 minus 7. And having drawn this and having given us some thought, we hopefully realize that if the thing is tangent, if the circle is tangent to the x-axis, that hopefully we realize that means that the radius is 7. Even though the value here is minus 7, the length of the line to the x-axis is going to be 7. And so as a result, again, having done the diagram, we have now made the sum pretty much the same as the 2 on the previous page. And so we can go, as I said, by inspection, x minus 5 squared plus y plus 7 squared equals 59, and we are done. Okay, so again, if they don't give a diagram, I would strongly encourage you to draw a diagram. It just helps make sense of it. We can see that this graph, for example, if they did ask further follow-on questions, that this thing has got 2 y cuts and a single x cut where the x-axis is tangential. We could think about answering questions about domain and range on the shape, all sorts of things. So again, I would encourage you to think about what sort of follow-on questions could come from this fairly easy example we've been given here. Okay, my last two for now, I do have another one in reserve, is to look at this one. A circle whose center is 4, 2, and who goes through 2, 5, the point 2, 5. So again, we can do a quick sketch. I don't want to take too long drawing the sketch. But we could draw a quick sketch. 4 minus 2 and 2, 5 would be, a good sketch would be there somewhere, for example. Sorry, last month this thing just bounces off. Neutral. Okay, we know that the center is at 4 minus 2, and we know that it is going to go through the point 2 and 5. So it's going to go through that point there. Okay, so we know that that point is 2 and 5. We know that that point there is 4 and minus 2. Okay, so we know at the moment that this is going to be x minus 4 squared plus y plus 2 squared equals r squared. We've achieved the first goal of finding the, so goal one, find the center, has been achieved. Okay, so what we need now to do is to find the radius. Now we can do it by one of two methods. One method is simply to substitute that point in. So method 1 is more algebraic, okay, and that is to sub in the point. So we're going to get 2 minus 4 squared plus 5 plus 2 squared is going to equal my radius squared. So I'm going to get 2 minus 4 is 2 minus 2 squared, which is 4, plus 7 squared, which is 49, equals r squared. So 53 equals r squared. We've got an answer then of x minus 4 squared plus y plus 2 squared equals 53. Okay, so there we've got our first method. It's not exactly my favorite. I prefer a slightly more intuitive idea. And again, the intuitive idea that I'd like us to look at is, as we spoke about previously when we were doing analytical geometry, is to look at the idea of the just doing the distance by a more intuitive method. Okay, so we can see that the change in x is 2. The change in y is going to be from 5 down to -2 is going to be 7. So we know that therefore the distance equals the square root of 2 squared plus 7 squared, which we should be able to do in our head because 2 squared is 4 and 7 squared is 49. So 4 and 49 is 53. And we have that our distance is 53. Just remember that when we do that method, that we are not looking for the distance, we're looking for r squared. Okay, we're looking for the square of r. Okay, so again, you can do it by a more algebraic method. Here, as I said to you, I've got my second method using a more intuitive idea of the idea that the radius is the same as the distance between those 2 points and moving on. Okay, what I'd like to look at now is this final example that I've got here also on the slide, and to look at what we're going to do now. Okay, so we are given that this thing has got endpoints on a diameter at, let's have a quick look here. Again, let's draw up a quick sketch. Okay, cool, not too problematic. We've got a point here that is at -4 and 1. And we've got another point here that's at 4 across and -5 down over there. And this line is forming the diameter of my circle. Okay, so we need to think about this diameter. What we do know about diameters is they give rise to right-angled subtended. Is that really relevant in this context? No, it's not. So what else do we know about diameters? We know that diameters run through the circle center. And we know that the circle center is going to be the midpoint of the diameter. So the first thing I'm going to realize is that the circle center is the midpoint of the diameter. Again, those of you who've been paying attention to some of my earlier lessons know that I do my midpoint in a slightly different way to some people. So -4, 1, 4, and -5. Okay, so the midpoint then will be 0 and -2, because if this thing is dropping by 8, so if this thing's going up by 8, then it must go up by 2 doses of 4. And if this thing's dropping by 6, then it must have a drop of -3 and another drop of -3. Okay, you can, if you like using formulae, you're well encouraged to use a formula, but we are not going to do so right now. We're going to use the midpoint. So we've achieved our first goal. We've got the circle center. What we now need to do is to find our radius. And again, you are most welcome to use either of the two methods we've discussed. You can use the idea of subbing back in. We now know that we've got x squared. Okay, and again, you can ask yourself where, this looks slightly unfamiliar, but it's simply x minus 0 squared plus y plus 2 squared equals r squared. We can sub in either point you choose. I'm going to go with -4, 1. So -4 squared sorry, -4 squared plus 1 plus 2 squared equals r squared. So 16 plus 9 equals r squared, which would in this case equal 25. And we have our sum. So x squared plus y plus 2 all squared equals 25. And again, 25 is a nice number, that's a perfect square, which means that we could realize, therefore, that our radius would equal 5. Okay, that might be useful for follow-on questions. Again, I have not taken the trouble to draw my picture here. I could have drawn it if I wanted to, We've got our diameter, so we need to have a semicircle going off the diameter over there, and a semicircle going off the diameter over there. And it's a bit difficult to draw on this platform, but there is my circle given. However, as I said to you previously, I like the idea of looking at it using a more intuitive method, and that is to look at the triangle. If this is the point 0 and -2, then the change in x is 4, the change in y is -3. Plug that in, and you're going to find out that r squared equals 16 plus 9 equals 25 using the distance formula. Okay, and so what we have here again is a setup where, very similar to find the equation of a line, where you've got two goals, find m, find c. In the case here of finding the equation of a circle, we've got two goals, find the circle center and then find the radius. The circle center can be found using either the diagram or information given to you, or don't forget certain tricks like that the circle center is the midpoint of the diameter. Okay, I want to look at one other one quickly, just because we can. Okay, so let's have a look at this one. Find the equation of a circle whose domain is x is an element of, let's go, for example, -2, and why not just simply make it 8? Sorry, -2 and 8, and whose range is y as an element of, let's make it 4 and 14. Okay, so we know that this circle would exist in, if we were to draw a quick sketch, we could do a quick sketch and say, cool, this circle would exist in this space over here. So we know that because we have a situation where the domain is between -2 and 8, we know that this, therefore, it can't exist out here on the far left or over here on the extreme right of my little diagram. Okay, we know that it can't lie between 4 and 4. It must lie, the range is between 4 and 14. So again, we know that this zone at the top here is out of bounds, as is the zone over here. So we realize that our circle would need to be drawn, would need to be centered somewhere over here and be drawn such that it does something like that, where -2 is the left-hand extremity and 8 is the right-hand extremity, and 14 is the maximum and 4 would be the minimum. Now, if we think about it, that gives us all the information we need to work out the circle center, because this shape has got a span of 10 going across it. So if that distance is 10, we should be able to realize that the radius will be 5, and we should be able to realize that the center of the circle will be at 3 and 9. Now, that comes from understanding the idea of domain and range, and it's quite an unusual forming of the question because they don't normally ask you questions working backwards from being given the domain and range. But again, we've been able to achieve our two goals. Our goal 1, find the center, which in this case is 3 and 9, has been achieved. And goal 2, which actually I think we achieved slightly earlier than goal 1, which was to find the radius. I think when we realized that the span across was 10, we realized that the radius had to be 5. So we've achieved our two goals. And so now all we need to do is to plug into our formula. And as I said, I would do this almost immediately without doing any major substitutions. So x minus 3 squared plus y minus 9 squared equals 25. I hope you enjoyed the lesson. Hope to see you again soon, shortly. Thank you so much.